Yep, I can see now. Guys, can you hear me? Post live. Okay, so now it's coming. Yeah, I can see it. I'm the only one who's watching. Uh, just give me a sec. I'm just right now looking at my phone to see if I can see it. Yeah, I can see it now. I can simply mute this thing. Okay, so guys, I'm really sorry. Actually, there was some problem. I connected the the live session, but with the wrong input or something messed up. I need to delete that. So when I recreated it, I found that it is not being created properly, so I need to just drop it. Okay, so welcome to the new live session. Today is day 5. We are creating. Actually, on day 4, we have already installed Postgres, right? If you have watched this one, there was one tiny mistake. So when you have that 4 option or 5 option, you need to check 3 of them. First one is PG server, second one is PG admin, and third one is your terminal client. You need to skip the builder part because it gonna occupy a lot of space, and my computer literally got hang, so I have to uninstall and reinstall it. Okay, just uncheck this one, and it will be good to go. It's very easy, and I'm pretty sure you can do it. If not, there's a lot of tutorial out there. You don't have to worry that much of this one. Okay, so before we move, the people who are new to the channel, let me quickly take you to this YouTube channel. All the videos is being uploaded here because we are doing the live session, so you can find all the videos. In case you want the quick summary in the form of graphical plus video recording, we also upload it here within like 5 or 6 hours, so you can completely come here and find the corresponding summary within 4 and 5 or 6 minutes, so that will be very easy to handle the things. Okay, so this is the first thing where you have to come and make sure you subscribe the channel, because then only you will find all the notification, because we keep on posting everything that gonna happen in next couple of hours. So you being keep updated with this. That's the first thing. Second important link that you have to come here is to search here in the description. You will find the link to the GitHub. There's my LinkedIn link as well. You can simply go and follow me there, because I keep uploading few of the graphical, like the workflow or the data flow diagram and many other things, that very snippet, or the article that I write in Substack. I also keep updated in the LinkedIn. So make sure that you also follow me on the LinkedIn. GitHub, we should come here because all the document we are doing in the GitHub. So once you come here, code for coin GitHub, you will find that I created 3 repository. We will go one by one. Like firstly, we will be doing SQL. So simply let's go here. So right now there are 4 directory. You don't have to bother with the first 3. Let's go to directly to fourth one. That's where we are currently working on. So you can skip this 000 because that's syllabus. That's I'm going to delete in future as well. It's just for reference. First one is Introduction to SQL. If you haven't watched, make sure you watch the live session. Second one is Roadmap. So we will open this one. On the third day, we study about the SQL. What is SQL? What is database? What is RDBMS? The fourth one is we gonna use PostgreSQL as our RDBMS. Okay. So if you come here, so this day is done. Installation is done. Now we're gonna start with the basic operation of this one. So let me open my OneNote where we're gonna write everything for our convenience. Okay. So let me quickly create. P05, that is your PostgreSQL database and table creation. Okay, so let's keep it very simple. Let me quickly drag it here. So that's gonna happen. What else is it? Before we move, let's quickly take 10 to 15 minutes to revise what exactly we learned in previous days. Okay, so it was today is day 5. So let's quickly go with the day number 3 and 4, just 2 days back. Okay, so let's quickly come here. So today is day 5, that's gonna come here. Day 4 and day 3, let's start day 3 and day 4 quickly here. So day 3 is all about SQL database RDBMS fundamental. Okay. So I will be very quick. SQL means structure query language that enables you to communicate with tabular form of data. Simple. If you want to know more, I have already covered it as part of live session day 3 and 4. Make sure you simply go and check. If not, check out the summary of that day that I already uploaded here. These are the one, and if you want to look all the data as a bundle or as a course, you can simply go here SQL 0 to hero. Okay, everything is there, everything. Okay, and there is day 1, day 2, day 3. Everything is written. It's very simple for you guys to check out. If not, I will make sure that I put the date at the end. Okay, that's on me. Okay, so that's one thing. SQL is very clear that SQL, uh, first of all, SQL is a programming language that enable us to communicate with tabular form of data. Okay, and in this tabular form we define this table as it. Okay, for SQL if we need to define what kind of a table we're gonna hold or host. So this is called table, but table is nothing but a collection of row and column. Okay, so table is nothing but a collection of row and column where row represent an entity or object. Okay, it indicated it represent an entity or an object outside the world. Okay, column represent the characteristic of that object. Okay, therefore table can be considered as, since row represent entity, right? This is entity 1, entity 2, entity 3. So table can also be called as or defined as collection of similar entities with same characteristics or attributes. Okay, I have given the example of a student. Suppose I am the student Nitin. My age is suppose 20 years old. I am a straight man. Suppose then is Robert. He is 22. He is also male. Then Raba. Her age is 19. She is female. Okay, so if you see, this is the table, and I can communicate through this. I can communicate this table with the help of SQL, because these are the similar entities, because they represent all the entities are the students of a university, and the characteristic or the attribute are the name, age, and the gender. Okay. And why we need to communicate? We can need to communicate when we need to get meaningful information through this format. Okay, let me give very good example. Suppose there are 3 students. I ask you what is the average. You simply sum all this age and divided by number of student, right? Since it's 3 is very easy. Suppose this represent the data set of university, and in a university there are multiple colleges. So the number of entities, number of student as a record in this one might exceed to 10K or like 100,000 records. Okay, then can you do it manually? No. So to get the insight in such formatted data, someone invented SQL that it make very easy, because it work on the concept of declarative. You simply declare what you need, and the corresponding software take care of it how it does. Okay, so remember, SQL is declarative that we already learned, so I'm not going much into it because we are already covered in the last 2 days. Second, so we are very clear with what is SQL, and we are very clear with the what is table. Okay, now we're gonna talk about database. Database is nothing but a collection of the table, or more specifically SQL tables. That's it. It's a collection of SQL tables, right? Now we are very clear what is SQL is a programming language that enable us to communicate with the tabular form of data. Okay, table, and a collection of tables that have relationship one with one another is called database. And a software that enable us these three features on a computer is called relational database management system. Very simple. What this relationship means, suppose this is an invincible boundary, okay, or call storage in your computer, okay, and you created one table of a student, then another table of college, then another table of prof. So many student can be studied under one prof, right? And one student can be studying only under one prof as well. Now this student and department does not have a relationship, but this particular prof have the relationship with the department as one to one. Okay, sorry, one to many. Dude, why this? No. So like many professor can be into same department, right? And one department can be into many professors. So it's many to many, sorry. So it's like no, one to many. No, one to many, yeah. One prof, suppose Prof A can be into mechanical department, then Prof B can be into mechanical department, then Prof C can be into computer science department. So many to one, but then one to many. Okay, so one, then one. Okay, this is one, but it's many, so it's one to many. So one prof can be into multiple, or many to one. I'm getting confused, dude. I told you that I'm coming back after a long time, but I think it should be many to one because many professor can be into this one department. So logic should be here is many means a group, and here is one entity. So many of this professor can be into one, this one, right? And one to one, then one to many, but this one, no, it's always one direction, right? Here it can have one at a time, and it can be, oh yeah, it's one to many. Okay, I'm sorry, dude. Now I remember. So what happened for relationship? Suppose this is professor, this is college department. Okay, so suppose these are different professor, and these are different departments. Okay, Prof A, B, C, D, and it is mechanical, civil, electronic, and what for one more? Okay, electrical, and is electronic. Okay, so if you look this way, this department, this can be in this department, this department. So there is only one ray going out from entity. Here it can receive one or many, right? So we will take the bigger number. So for an entity, what's the maximum number of linkage you can say it is one. What is the maximum linkage you can say it? It is more than one. So more than one is m. That means many. So ratio is one to many. One prof and many of this one. Okay, I need to double check on this one, but I'm pretty sure this is how it is. But okay, let's quickly back into RDMS. So So this kind of a relationship we can establish within the database where the table that have a relationship with one another exist together. Okay, that's why this is called relational database because it's a relational. All the tables in that database have some kind of a relationship. So I'm not going much into it. So we are very clear with the SQL table database and finally your relational database management system. Do we have anyone join? Okay, I think we don't have anyone join. So I was about to ask if someone have any questions, but since I'm the lonely wolf here, so we don't need to worry. There's not a single one. Yeah. So let me quickly go back to here. Okay, so we are clear on these three things. And if you want to read more, I have put everything here in a well-defined manner. You can simply quickly check it. Will take less than 5 minutes for you to have a quick glance. Then quickly go to day number 4. It's about the Postgres. So Postgres yesterday we learned a lot. So I think it's not 177, it's 170. I need to change this one. Okay. So first of all, Postgres is an open source and free object relational database management system. And since it's a free and easy, free to use and open source, you can simply play with it. You can create your own uh, extension of PostgreSQL and release it into the market. It's totally up to you. It's free to use. You can do anything and everything. That's the best part of it. And this was being invented in University of uh, California, Berkeley in 1986 after 16 years of when Edgar F. Codd gave the relational model theory. And after which 4 years later, 1974, when IBM researcher developed the first SQL and your SQL and your relational database management system, or basically SQL. Um, University of California, Berkeley, United States. It was in 1986. Okay, so there's nothing much here. But what the best part I like about the Postgres is it's very much personalized or customizable. So you can create your own custom data types, then you can create your own custom functions. Plus, it is extendable to 4 procedural languages. Procedural languages like those languages which can write functions and call the function as a executable blocks. So Python is one of them that I love. TCL is one. Perl I think is one, and one is PGSQL. But I think there are something different. I need to check this. Okay, open source, highly extendable. So you can define own one. This one, PL. This is the programming language, and it can support 4 languages that I know. The PGSQL. So PostgreSQL, it can you can write your own function on this one. Then TCL, Perl, Python. Mm. So I have given few example. You can write it or you can say it for your convenience. But we're gonna go much into detail as we proceed with our roadmap. So you don't have to worry. And since you are integrating a different language in a database, right? So usually database or relational database management system usually represent as a cylinder. Okay. Relational database management system in which there are different databases And if you're creating a snippet of code using Python or something and you want to integrate it, that means you need one interface that help us to communicate with these two, right? This is called handler, that is made in a built-in C language, and what it does either of two tasks. Either it will go and execute everything of the program and then integrate the solution into your database, or it simply act as a messenger. A separate environment execute this one, the result or output will be processed to handler and handler will communicate to this database. So this is the best example of data locality that I learned today, dude. I write this in my article. If you want to read it, every article link is available into the my link, but I will make sure that I put my article link. Let me show you quickly. So I usually keep my article on Substack website. So whatever we are teaching, I try to write down as form of article. If you have a time, simply go and have a read. It just take less than 5 seconds, but 5 minutes, but it give you more exposure. I think this is the one truth about this one here. Relational data look. I mean, look, I think it was the philosophy. uh, we'll leave it. We don't have a time. Maybe some other day. Leave it. I will say it. Okay. So data locality means when you move, suppose you are here end user, okay? Usually what happened on your computer screen, all the data is fetched on your system and then your code execute, process the data and give you the result. Now the approach in a lot of big firms change with this concept of data locality. What happened? Keep their data into their own computer or server. Whatever request you ask, it will throw the code here. It will take the code here and execute the code in their own system where the data is hosted. So now there is no latency of data being transferred from the server to your computer. The code will come here, it will execute and give you the result as it is. So what happened? The time is reduced because now you are just sending the code and the output is usually, see, when you're processing the data, you're getting meaningful data, right? So meaningful data is always less in size than actual data. For example, if you have big Excel with all the student and their age, and I want the average is one cell, right? So which one occupy more space? This entire sheet where the name, everything is there, or just the one value that is average of student age? Obviously, this is the one. So data locality work in the same manner where you move your code to the data rather than data being moved to your local system and then code executed on over it. Okay, so that's data locality. It's really good. Okay, let's quickly. This is done handling, nothing much. Load call handler return. So with this, day 3 and day 4 is completed. Let's quickly go into our today's task, that is this one. And for your information that we are using the Bible, that is Postgre documentation for our learning. So we will go about governance, all this one. Developer support your account, about uh home release. I forget where was the I think it should be documentation, book, release note, documentation, manual, release note, book, tutorials, another. Okay, yeah, this is a tutorial. PG Media, a detailed encyclopedia of physics-related topic, including how to feature information. No. Postgres tutorial, learn Postgres and how quickly start with the example. This is the one. Tutorial point of this one and PG exercise. I think PG exercise is the one I'm looking for. Excellent. Welcome to the Postgres exercise. This site was born when I noticed that there are a lot of material out there to help people learn about the SQL, but not a great deal to make it easy to learn by doing. PGX site provide a series of question explanation built on single simple data set is designed for use as a partner to a good book or Postgres excellent documentation. The exercise on this site range from simple select and where clause through join and case statement and on to aggregation, window function and recursive queries. Okay, so that's all for introduction to get data. Go to this data set. Okay, so now we are here. Postgre tutorial, we can keep it outside. Postgre tutorial, let's keep it outside. We will go with this one, the actual Postgres. Okay, so we learn about the Postgres, we learn about the history convention. So what is Postgres? So Postgres, so simple question should be asked. First one is what is Postgres? We know that Postgres is an object relational database management system. What is object? What is relational? Relational, we know that in a database we have tables that have some relationship with one another, forming a real world type relationship. Okay. So that's why this is called relational database. But object, I am not sure. We need to learn about this one. Based on Postgres version 4.2 developed at the University of California at Berkeley Computer Science Department, Postgres pioneered many concepts that become available in some of the commercial database system much later. Postgres is an open source descendant of its original Berkeley code. It supports a large part of the SQL standard and offers many modern features like complex query, foreign keys, trigger, updatable views, transactional integrity, multi-version concurrency control. Also, Postgres can extend by the user in many forms, for example, by adding new data type, function, operator, aggregated function, index method, procedure language, and because of the liberal license, Postgres can be used, modified, and distributed by anyone free of charge for any purpose, be it private, commercial, or academic. This is the one I was talking about. This is one of the best license you can ever have because the Postgres is built in such a manner that you can create your own product out of it and you can sell as commercial object or your own object to anyone and everyone. That's the best part of Postgres. And since its utilization or its usage in the commercial level has increased tremendously, so you will see a good number of people working on the releases. So you don't have to worry about someone not fixing any bugs or something. And since they have already released 18 version, I think it is much more stable and it provides you with a lot of things. So I do love about this one. So let me open my sheet as well. So already written here and PostgreSQL compile with 170 features. There are still 7 left, but it's a big thing for a relational database that provide a lot and is still compiled with 170 out of 177 mandatory feature of SQL. That's the big achievement. So we learn about what is Postgres. Postgres is nothing but relational database management system, but it have two distinct feature. One is your object. Second one is about your relational that is always occur. Object, I'm not sure. Maybe it is storing the values or the table as an object or something. I need to check out this one. I'm really not sure. Let me check why PostgreSQL is called object relational database. Postgres is an object relational database management system, which means that it has relational capabilities and object oriented design. Using object-oriented feature of PostgreSQL programmer can communicate with the database using server using object in their code. Okay. It has relational capabilities and an object-oriented design. So object-oriented design, it has object-oriented design. That process is stored. I want to understand like whether it is stored the table as an object or it is stored the entities as an object. So PostgreSQL does it store entities of table as object or does it store table as object? Table indexes and sequence are stored as individual files. Each object such as table or index is stored in a separate file. These files are also named using OID assigned to each of them. Uh, each table is stored as a file in Postgres each table. If table contain more than 1 GB of data, the rows are divided into multiple files or segments, and each additional file name is suffixed with a file number. Uh, Cloud AI. That's the best part when you don't have to do much research. You understand the concept. You can simply come here and ask what exactly you're looking for. But meanwhile, I need to check does it have why it is called. So, for the brief history, we already learned about this one, and we are not going to delve into it because this is not something people gonna ask you. Now, conventions. Meanwhile, it's loading. I need to see. What is conventions? The following convention are used in the synopsis. In the synopsis of a command, bracket and indicate optional part and braces and vertical lines indicate that you must choose one alternative. Okay. So bracelets means optional part, bracket means optional, braces and vertical line means you have to choose one of them. Dot means that the preceding element can be repeated. All the symbol including parentheses should be taken literally. Okay, where it enhance the clarity. SQL command are preceded by the prompt equals to and greater than and shell command are SQL commands are preceded and shell command are preceded by the dollar sign. Normally prompt are not used through an administrator generally a person who is in charge of installing and running the server. A user could be anyone who is using or want to use any part of the Postgres SQL system. These terms should be interpreted too narrowly. This book does not have a fixed presumption about the system administrator procedure. Okay, so this means optional. This or this means any of the one. And dot means that preceding element can be repeated. I need to check how and where they are using this. Bug reporting guidance. Further information, Wikipedia website, the Postgres website carries detail on the latest release, other information, mailing list. The mailing list are a good place to have your question answered, to share experience with other user, and to contact the developer. Consult the Postgres SQL website for the detail. Social PostgreSQL is an open source project. As such, it depends on the user community for ongoing support. As you begin to use PostgreSQL, you will rely on other for help, either through the documentation or through the mailing list. Consider contributing your knowledge back. Read the mailing list and answer question. If you learn something which is not in the documentation, write it up and contribute. If you add feature to the code, contribute them. Okay, this is interesting. Like if someday I feel like I'm good enough to look into this one, I will definitely contribute, dude. They gave you something free for humanity. Trust me, I will contribute, and in future if I can make something that can contribute as well, I will definitely do it. But at my current level where I am worse than a junior developer, trust me, I need to go way ahead. Okay, this guy is not working. I typically use cloud AI. We are working on it. Leave it then. I will check and get back to you why the object. Bug reporting, identify bug. So this is not for us, but in case you find a bug or something, you can simply refer to this one. They must have a mailing list or something that you can simply raise your thing. So now, like, let's get started with the installation. But installation we already created, right? We are done with the installation, so we are not going into this one. Okay, tutorial getting started. So this is the tutorial part one. Part one. This is the one getting started, and this is the getting started. The SQL language, an advanced feature. An advanced feature. So today we are not going to cover everything, but we are mostly interested as of today. The number five is to create our database, create our table, drop and alter, whatever the basic we need to perform to establish as a beginner. So installation is done, so we don't need to bother of this one. Architecture fundamental. Okay, let's read this one. It will give us some understanding. Before we proceed, you should understand. Before I go, let me check if somebody joined and they have a question. Why am I even checking there? I can check here. One watching now. I think I am the only one who is watching. I guess so. I go. Okay, let's quickly back. Before we proceed, you should understand that the basic Postgres system architecture, understanding how the part of Postgres interact will make this chapter somehow clear. In database jargon, PostgreSQL uses a client server model. Okay, client server model. It use client server model. What is client server model? A PostgreSQL session consists of the following incorporating process. What is client server model? Client server model. Client server model is a distributed network architecture where client or user device request services or data and servers powerful centralized computer process those requests and return the information. It enables efficient scalable resource management such as web browsing, email or cloud storage using this one. A user-facing application, web browser, mobile application that initiate a request for data or services. A server, a centralized machine or software that store resources, manage data, and handle multiple client requests simultaneously. Request response cycle, a fundamental interaction where a client send a message to the server, which process it and return a result. The request response cycle. Network protocol rules HTTP and HTTP IP useful. Okay, so before I move, okay, so let me very quickly tell you what is client and what is server relationship or model. So simply what happened, client means you guys, and you as a human need to interact with the machine. So you need firstly a machine that enables you to do that. So this is your computer. Okay, this is your computer. Now there's another computer here whose IP or domain, for example, www.google.com. Okay, so when you type this one, it at backhand convert to IP address in a router somewhere, and then this IP address search for that computer. This IP is nothing but address to the computer. It goes here, and whatever request you ask for, suppose you ask for how to become a good developer, it will go and give you the request to the Google server that he needs the result on how to become a good server. So now this is a main server. It does not have the information. There are multiple, many different computers it is linked to. It will send a request and see which computer hold the corresponding information. It will curate those data and provide you the link with those as form of web browser. These are the link to the corresponding web page he found relevant to this request. So this is called client server, where your client send a request to the server or computer where it hosts the service or the data you want to retrieve. Okay, and this cycle of sending message or request and then here processing and then curating and then getting back to you is called the request response time. Okay, and our Postgres also work on this one. So what happened, your Postgres is either, so Postgres is a software, so it need a computer CPU to store, right? So if you are not connected with the web, you can install this in your own personal computer or your local machine. Okay, so see, if machine is hosted in some other place or in some other, like suppose you are A, your friend is B, and it hosts an application, so you need this IP address to go here, right? But you find it that is cumbersome, you don't have internet, you take that copy of that software, install in your computer. Now the IP that you're gonna have is the localhost localhost IP. That means when it will take this IP address, it will automatically reroute the request to your own computer. Okay. Similarly, Postgres as a relational database management system can be installed on your computer or it can be installed in some other computers. But if it is installed in some other computers, you need their IP address or domain. If not, if you install in your own computer, when you will try to log in and connect to your software, you just need to provide localhost as IP. IP means the computer where it is hosted. If it's in your own computer, then localhost URL will be needed. If it's somewhere else, then you need a proper URL. And now, since it's hosted somewhere and you send a request now and it get a request back, that's why it's a client server model. Okay, so that's nothing. A server processes which manage the database file, accept connection to the database from the client application, perform the database action on behalf of the client. The database server program is called Postgres. So I told you Postgres as act as an intermediary which enable you to store and process the data by sending the SQL query command. So SQL query command send as a query that I need this one, and all the other things is being taken care by your Postgres server. And that's why it's called client server, because you send a request, server processes and get back to you. You are not doing anything. But Let's take another example of Python. In Python, you need to write everything start to finish. You are not sending a request that I need the information. You do all the processing altogether. So here is not client server. It's you yourself is the client. You yourself is a server. Boom. Okay. So the database server program is called Postgres. So it's not a big deal. The user client front end application that want to perform database operations. The client application can be very diverse in nature. Client could be a text-oriented tool, a graphical application, a web server that access to the database to display the web pages, or a specified database maintenance tool. Some client application are supplied with the Postgres distribution. More are developed by users. Okay, it's not a big deal. As a typical client-server application, the client and server can be on different hosts. I told you this, right? It can be on your own computer or it can be on someone else's computer. In that case, they communicate via, if in someone else, it communicate through web browsing or internet where you need IP address. If it's in local, you need the local IP address. Network connection, you should keep this in mind because the files that can be accessed on a client machine might not be accessible or might only be accessible with using a different file name on the database server machine. The Postgres server can handle multiple concurrent connection from the client. To achieve this, it starts forks a new process for each connection. So fork is nothing but it give you an instance. It gives you a processing power, memory, and everything as an individual connection where you can work on. So from that point on, the client and the new server process communicate without intervention by the original Postgres process. Thus, the supervisor server process is always running, waiting for the client connection, whereas the client and associate server process come and go. Okay, process always running, waiting for a client connection, whereas the client as associated server process this one. From that point on, the client and the new server process communicate without intervention by the original Postgres process. Postgres server can handle multiple concurrent connections from the client. Clients achieve this at the start for a new process for each connection. From that point on, the client and the new server process communicate without intervention by the original Postgres process. Okay, thus the supervisor server is always running and waiting for the client and associated server process come and go. Ooh. So uh, in the client and the server model, what one thing that we need to understand, like if you are a client, you are today sitting like, for example, like I'm sitting on my computer, okay, and the database or relational database management system, okay, is hosted in your computer here. Okay, it is stored on your side, yours. Okay, and I have IP address to your computer. I know the port where I need to connect and get access to your database, and to connect it to your database I have a username and password which is stored in your username and password for authentication. Okay, what I will do, I will create Python program or I will install one predefined software that's already coded in Python, Java, whatever it is. I just have to put IP address, username, password, and everything detail. Either of them, but whichever I'm using, it will enable us or enable me to connect with your server, the first interface. Okay. So that's why it said that you can use multiple ways to connect to the server, which is hosted either in my own personal computer that is local or it can be hosted in your computer, right? Now to process this one, what happened when the request came, this supervisor server, what it does, it create a funnel a tunnel or terminal specific for that request. And now whatever the process happen, it will go through this one. Now suppose there is another one, me, it's also requested this one. So it will, so it's a kernel or kernel or process one. It will create an individual isolated process too. So these two won't interfere. Now, once this is done, it will automatically enable you to connect to your database and it will enable to you connect to the database. Now it's again free, but is waiting, is working and waiting. Once this process is done, my database become idle again. But this is continuously working, it is watching. So if you have to see an analogy for this to understand, let's take an example of hotel where chef is working. This is a table, okay? This is the table, let's say. And this is the guard. Okay, this is the guard. And this is the client one that came in. Guard look at his invitation. Okay, everything match his name, match his reservation, match everything is matching. Okay. Then he will assign a seat for him that you sit here. Once I sit here, then I will ask the chef that please cook this particular for me. Now another customer C2 came. Okay, he came first, then he came. He looked at this one. Okay, he said you have reservation, you have everything is there, your name is there, your password is there, everything is there. You are authentic person. He will give him another stool. He will come and sit here stool. Suppose there are three stool available. Okay, he will ask the chef again now that I need some meat. Okay, he is like vegetarian, he need meat. At that time third person came. He is like, okay, authenticate me. He was like, okay, your details is there, you will go, he will sit here, and he's a vegan and he asked for the detail. Now the fourth person came and he was like, I need to authenticate. He said, you are not present in this list, your username and password is not matching, so I cannot allow it, so his request is cancelled. Now fourth person came, he's like, this is my username, password, everything, authenticate. Bad check. Oh, he said, oh my god, you have everything, you're right. But right now all of our resources are occupied because we have three seats, we don't have four, right? So you need to wait. So he will send a response that you need to wait, try after some time. So that's something you find when the server is overloaded, you cannot access it because of this reason. Okay, once this is free, suppose he is done with eating and he goes back. Okay, C1 is completed, misrounded. Now there is table available. He comes back again. Now he will sit here. All three is occupied. Okay, so that is the optimal use of resources at a time. Suppose two is done, he went by, he's done. Three is also done. Fourth one was cancelled. Okay, let's this, and he's also done. Now look at this one. When there was no customer, the guard was still working, but the chef was idle. When the first one came, he started eating. He's still looking for other job and he started working. At the end, when everyone went out, he is still looking for another customer to come, but my chef is idle, right? So now you need to understand these clients are nothing but you people, customers or the clients. This guard who is watching for the people who are coming in for services, he is nothing but your supervisor server, or it's called master node. And the chef is nothing but your relational database management system that get the request and then process the data and give it to you. So this is how server client work. Okay, but any doubt on this one, because this is not that tough, but it's not that easy as well. And I'm happy to answer if you have any question on this one. Why am I always opening this way? Okay, there is no one. Dude, I think I won't be able to cover this. I need to cover now creating a database. So I told you database is nothing but a collection of relational tables or the tables that have connections, right? Creating a database, the first test to see whether you can access the data. The database server is to try to create a database, right? A running Postgres SQL server can manage many databases. So that means In a relational database management system, you can create multiple databases which will hold multiple tables, relational tables. Okay. Typically, a separated database is used for each project for each user. See, I told you. For different project, you will create different database so that all the tables don't merge in the same space, and it will become hard for you to from many perspective. If you keep everything in one place, it become hard to manage, it become hard to understand the workflow. Third is over exhausted. Fourth one is from the security perspective, everyone can access it, and that's not the right thing. So to create a new database from the command line, in this example name mydb, you can use the following command. So this is something we learn in the convention, right? If we are running through a command line or command uh, prompt, then we use dollar to represent that this is a PostgreSQL command. Okay, create db mydb. So see, I told you SQL is nothing but completely English based and is declarative. You simply define your intention, and how it gonna do is totally up to the SQL relational database management system. And connect with it, we need SQL server, sorry, Postgres server that enable us to connect with this database. Okay, so create db mydb. If you proceed this for no response, then this step was successful, and you can skip over the remainder of the section. Okay, great DB command not found. Then Postgre was not installed beautifully. Either it was not installed at all, or your shell research path was not set to include it. Try calling the command with an absolute path instead. Okay, user local pg bin and then create db and mydb. So to create a database, you need to use this command create db. db is database and then database name. So simple, dude. The path at your site might be different. Contact your site administrator. This is nothing to worry about. Connection to the server on the socket, this one. So whether your own login is not mentioned, this will happen if the administrator has not created a PostgreSQL user account for you. So I told you that is a software you need that gatekeeper to remember it authenticate. If you are not in that list, you won't get entry. That's how the number fourth person feel when he tried to enter, because his name was not in the reservation list. Okay, so but make sure your credentials are being part of that reservation, then only you can access the Postgres or the particular storage of that relational database management system, that is particular your database. Database creation failed, permission denied to create table. So this is another one. Again, I told you from a security perspective, at database level, you are being provided. So first is you can access it. Okay, so read only. Then you need to get the right access as well. So then only you can write it. Not every user has the authentication to create authorization to create new database. Told you. So administrator who have the all the power, he have the power to you, power for you to create the credential for you. Second, it give the particular set of power for you, like either you can access it either, or you can access and create. So you need to ask for creation as well. So remember, if Postgre refuses to this one, is you need to connect in this not a way. Create DB. So if you do not want the database anymore, you can simply remove it, drop DB. So command is so simple, create DB, then the name of this one, and then drop DB, name of this one. That's it. Okay, let me quickly open the relational database management system. That's UI that enable me to connect to the uh, my databases, okay, or my relational database management system. So I need a UI that connected. So I can either write a code in Python, but that I won't do it. I want very simplistic or minimalistic. So I will use a software which will provide me a user interface that help me to connect with the server. Right now the server is local, or the server means where my application is hosted. Right now my software is hosted in my own computer. So let's go to PG admin. Here it is. So PG admin is my GUI or user interface that helped me to connect the server. So meanwhile is happening, so I will put down few things. So firstly, client server, you got it model, right? So client needs something to connect with the server. Server is nothing but computer where application is hosted or present. It can be either on local or it can be on any computer. If it's in local, then you need local IP, and if it's in some other place, you need a proper IP. Make sure your credentials, username and password is included in that list of authenticators, and then you need the corresponding authority. Like you just need the read access, you need read and write access, whatever it is. Then only you can access, and then only you can access and modify or update the tables based on your requirement for those database. Okay, client side, either you can write a Python code from scratch, or you can use some interface, predefined or pre-constructed, pre-built software that help you to connect. Right now I'm using this GUI is pgadmin, and the one who helped me to connect with me with the relational database management system of Postgres is PG server. So my request will go to this one and it will goes to here. Then it will come here and simply go ahead directly. So once you install it, it's gonna look like this. This okay. This is the GUI that enable me to connect. Now let me show you. If you go here, so see this is the GUI that enable me to connect with this one. But firstly, let's go here. This is the server I told you. This is where my application is hosted, relational database management system. And this is where it will help two things. First one is store the data in databases. So it will help me to organize and manage the data. Second, it will help me to access and play with the data or operate on the data. It will give me the meaningful information based on my requirement. So server is the one. So this is the server and this is my relation database model. So my request goes to the server where my this application is hosted, relational database management system, that does two things. First is to store all this application. Second one, it enable me to execute SQL queries to get me or fetch me the data. So if you see here, schemas. Schema has one thing that is public. Public is like is it have all the features like you can read everything. And then here is the table. See here, this is the one where currently we don't have any tables inside it. But you see it here. We have this server and the server name. Do we have a server name? It's the server name itself. Its ID is one and name is server. Okay, no worries. Then RDMS. Okay, I think you can create more relational database management system using it, but I need to check. I think it's just Postgres only. Then it have only one database here, Postgres. So we're gonna use this one. Okay. Then this is the what I was talking about. The PG check, PG create subscription, owner detail, all this one. So PG admin have the administrator or the one who take care of this one will have all the access. So you don't have to worry. Now query tool and this P-SQL work tool. Is it? But right now this is the welcome to query tool. We will come here. Now we need to select server. Server is like the computer where it is hosted. So if you drag down, is already this server. This is the server we have created that is present in our local. Okay. See IP local. If you want to create a new one, you can simply go here. I think you need to create, you need to select this one, register, and then you can deploy, create. Then you can create a server group where you can put the information where it's hosted. Then you can select that one in this one, and then you can connect. Then you create that particular pipeline to connect to that computer, and then you can play with this. Port is there, post. So now, right now, there's only one database, right? Yeah, this is the database. So why don't we create one more database here before we connect? So let's go here. So here is one database. Let's click here. Let's click this one. Register. No, I need to create, and I need to create a database. See here, database. Now I told you either you use the Python code, then you need to write all the commands. As in GUI, it will automatically take care at the back. But we should know the command create DB, drop DB. Simple. So now let's create a student. I love a student. OID, I don't think I have. Owner is Postgres because I think I am the one Postgres. Command is nothing. Let's quickly check for the one. Do you our change will be lost? Are you sure you want to close? Yes. Let's quickly go here. And it was Postgres, right? Name Postgres Orchid ID 10. I think that's the one. I am the one who log it as a Postgres, I guess. Let's see if I can create one. Create database. A student Orchid ID I don't have. And definition security privilege grant parameter advanced and SQL. So see here, create database student with owner Postgres encoding this one, this one, this one. You are using see that create DB is the one, but this is the Postgres format to be very frank. That one I never use it. I always use like this is the create database. I need to check. So if you use the command line, then you need to use that one. If you use this GUI, then you need to use like create database proper one. Okay. So in GUI is like always create database and then database name and then just the save. See here now student is created all this one. We don't have any table, so table in the subscription should be empty. Now let's access this one. Local Postgres, no database. I need reset. No. So let's copy this one. Local host port. Okay, local host 5432. Local host and 5432. So here the server is created. Here I'm trying to connect to that server. Database is student, right? User PG admin. Password. You need to have your own password. Let's see. Please enter the password. Uh, oh, username. Student. Postgres. Postgres. Okay. And databases. Student. See, now it came. So you just have to select your server here. It will automatically select everything. Here, Postgres and this one, template 01, you don't need to bother. Student, we created database, right? Password, I don't think we need it. Please enter the password. I need to check if it's the same password that I used to log in. Yep. So for the first time when you use it, it will ask for password, and that's where I put my password, and you guys might know because I used yesterday as well. So we are officially created our first database student there where we can create multiple things in future. But so see in that GUI, so in PostgreSQL, Postgres, like PostgreSQL, create database name with and all this functional, all this feature you want to give. But if you're using command line, then it's like create db and drop db. Okay, accessing, we already used accessor, but we are not going through this one. This is command line. We already have pgadmin GUI that enable us to do far better than this one. So we are supposed to close, create, drop table. I think we will not be able to do it today. Okay, so let's see if so. How about we try to? So we already created a database. Can we delete the database? It will be more fun to do that way. So this is the Postgres one, right? We are not using it. Right click, refresh, restore, backup, create, ERD for database maintenance. We don't have the one, but since we are already here, this one, drop database student, execute. Let's see and execute. Database. No, we are not dropping student. We will drop Postgres database. Okay. So it's executing, dude. It's executing. It's executing. As data Postgres is being accessed by other user, there is one other session using the database. That means we cannot drop it time being. Okay, can we close this one? Do we have something that ERD creates per store? So no, right now I don't know, but this is the one that we use it to drop database as a Postgres. Okay, I need to see. I think we will stop this today, and tomorrow we will be getting into database table creation, like create, drop, all this one, and concept like creating a new table, querying a table. I think join one we won't get into it, but introduction concept, creating a table, populating a table with rows, and querying a table. This is the basic thing we will do tomorrow. This one, create, drop, and alter a table. Okay. I think I took more time than required, but yeah, from tomorrow onwards, I won't take more time on like discussing all thing. I will just, it's fun, dude. That's way the learning is more easier. But today we learned a couple of things like how to create, how to access first this thing, then how to connect to your server, what is server client relationship, how it work for our Postgres, how the client we are using instead of using Python code, we are using proper GUI provided by Postgres, that is pgadmin, and then we host, we install our software in our local system, and the one who work in between these two is PG server that take the request from this one and check if the database relational database management system is work available or not. If yes, it will provide it. It's authenticate as well, and then all the request is processed, and then we get the result. So at least we basically learn the architecture of Postgres. That's a good thing. Then we are able to connect with our server that is hosted locally, and we were able to create one database without any table. That is the student database. So that's a big achievement. Congratulations. If you are following it, you are doing good, pretty good, dude. I'm proud of you. But is there anyone I can proud of? Like anyone? Five. No. I think with this I will wrap today's video. I need to go for my part time as well. But thank you for joining today. I really love you all. Just two subscriber. I got one subscribe from yesterday. I think that's it for today. Tomorrow we will be diving into the tables. Okay, I thought we can cover that up, but because I have to go, all else I would have like extended half an hour more. So with this, I will take my leave. I hope you guys learned something. I love you guys. Bye bye.